Hi everyone, thanks so much for joining us today. My name is Keegan Marazi and I'm a Partner Solutions Architect here at AWS. Today here I'm joined with Jeff.
Hi everybody, I'm Jeff Bloom, the Founding Principal Solutions Architect at Wiv.
So we're here to look at a question that's been asked by a lot of customers. Someone on the finance team comes in and asks, why did Lambda cost spike last week? It sounds like a pretty simple question, right?
It does sound simple, but it's actually one of the hardest questions to answer in FinOps. Because to answer it, you need to investigate. You need to pull data from multiple AWS services, reconcile different query models and response schemas, correlate those signals across systems, and then isolate the underlying root cause.
Wow, that's already a lot more complex than I originally thought. Can you give us a real example of how painful this is for customers?
Well, last week, one of our customers had their CFO walk into a meeting asking exactly this question. The engineering team then spent 3 hours across 4 different AWS services before they could give an answer. So the question is, why is this so complicated? Well, let's take a look. To explain a Lambda cost spike, you need at least 5 distinct data sources. First, you need Cost Explorer. That's going to give you the spend breakdown, as you can identify which functions drove the increase week over week. Then you need CloudWatch for the operational telemetry. Things like invocation counts, duration metrics, and error rates, so you can determine whether usage behavior actually changed. Then you also need the Lambda API. That's going to give you the configuration state, including memory and timeout changes. But then you also need the cost and usage report data. You can get that through Athena, and that gives you the line item billing detail. And finally, you need savings plan data to help determine whether the issue is usage-driven or is it coverage-driven. The complexity here is that each of these systems has its own query model, its own authentication pattern, and its own response schema. So what looks like a simple cost question is really a multi-surface correlation problem across AWS billing, telemetry, configuration, and coverage data.
Well said. Speaking of Lambda cost spikes, answering questions like this fit into a key pillar of the AWS well-architected framework, which is known as cost optimization. It focuses on the ability to run systems and deliver business value at the lowest price point while maintaining performance and security. So let's see exactly how Wiv solves this problem. Can you walk us through the architecture?
Absolutely. Wiv's entire flow runs on AWS. Starting from the left, the user asks a natural language question in our Wiv UI. Why did Lambda spike last week? The prompt then goes into our engine on AWS Bedrock, where Claude Sonnet parses the intent, selects the right step templates, and injects the customer's cross-account IAM credentials. From there, the engine generates parameterized calls to services like Cost Explorer, CloudWatch, Lambda API, and Athena, and then it's unifying the results into a single answer. Everything stays inside AWS. The inference runs in region on Bedrock. API calls go directly to the customer's own services. Credentials are isolated per tenant, and customer data is queried in real time and processed transiently in memory rather than being stored outside their AWS environment.
You know, that's a really good point that you left off there. There's a huge differentiator for customers dealing with sensitive data, especially enterprises and industries that handle personal identifiable information or valuable banking data. So it's really important for compliance and safety standards to make sure that their data does not leave their cloud, in which case this architecture really supports that security and compliance for many different enterprises.
Let's zoom in a little bit on the integration engine. Let's talk through the core pillars. There's really 2 core pillars here. First is the credential store. Each tenant has its own IAM roles and tightly scoped permissions across those services like Cost Explorer, CloudWatch, Lambda, and Athena. And then second, there's the step template library, which contains pre-built parameterized templates for each supported AWS service. We have the spend analysis through Cost Explorer, those operational metrics from CloudWatch, configuration state from the Lambda API, and line item billing detail through Athena. Now, Claude's job here is not to invent raw API calls on the fly. It selects the right template, injects the right parameters, and lets the template handle the service-specific syntax, pagination, and response parsing. That's how we make the system reliable, repeatable, and scalable.
You know, when AWS releases new services, there's different APIs to track them. And when there's new services, there's got to be new ways to track them. So how does Wiv and its customers really stay up to date with these changing services and these changing APIs?
Well, to keep up with AWS's pace of innovation, we use template versioning. When AWS releases a new service or updates an existing API, we add a new template to the library. Claude automatically has access to it on the next request. We maintain the template library, and Claude's selection mechanism picks the most appropriate version for the query.
You know, that's a really great example of customer obsession, ensuring that the user experience is as seamless as possible, even with the constant pace of innovation. Speaking of Claude and multiple APIs, Amazon Bedrock actually flips the script by giving you a single unified API to access any foundational model you need. Speaking of this, Jeff, can you explain how Amazon Bedrock and Claude Sonnet specifically work to power the platform?
So our flow breaks into 4 different stages. First, Claude is parsing the intent all the way on the left. It's identifying the target service, the time window, and the fact that this is an anomaly investigation. Second, it selects the appropriate templates, because answering a question like, why did Lambda spike last week, requires those multiple service calls, not just one. That means pulling spin data across all those services that I mentioned earlier, as well as the telemetry and the configuration state. Third, it injects tenant-specific context into each template, including the IAM roles, account IDs, and the regional scope. And finally, it executes those parameterized calls inside the customer's environment. Since inference runs on Bedrock, data never leaves the customer's AWS boundary, so we thought about compliance and isolation and built it in by design.
So Claude selects Cost Explorer for spend, CloudWatch for metrics, and Lambda API for config, all from one natural language prompt. And each gets its own credentials injected and executes them in parallel.
That's exactly right. Claude is handling the template selection, parallel execution, and response unification. And that connects directly to the orchestrator architecture we're going to cover in our next video, where more complex questions require coordinated reasoning across multiple AWS data sources.
Okay, so let's bring it home. What does the before and after look like for the original question? Why did Lambda costs spike last week?
Well, if you remember that original investigation that we opened with, without Wiv, that took 3 hours and was a very manual process. But with Wiv, it becomes a 5-second answer. You ask one simple question, why did Lambda spike last week? And you get a root cause analysis in seconds without writing any query syntax or jumping between screens. But the bigger value here is not just speed, it's consistency. Every single investigation runs through the same rigorous process every single time.
That's a great walkthrough and good explanation on how Wiv really differentiates this tedious process of identifying cost spikes. Thanks for breaking this down for us, Jeff.
Thank you for having me. If you'd like to learn more about Wiv, take a look at the links in the video description, and you can also find us on the AWS Marketplace.